We're going to begin Geometry Unit 6, which is transformations, moving things around a coordinate plane. So when we translate a point and give its coordinates, we're sliding. Translating is moving things side to side or up and down. So when you translate up and down, you're adding or subtracting to the y coordinate. And when you're moving things left and right or side to side, you are adding or subtracting to the x coordinate. All right, so now let's see what this is asking. In this translation, we are going to translate the figure 7 units up. First, we need to write the original coordinate. It says give the coordinates of the marked point. So you can see there's the dot. The dot is at 5, -5. All right. Now we're translating the dot. It says what are the coordinates of the dot? If we're going 7 up, we're going to add 7 to the y coordinate. So let's go over here. -5 plus 7 equals 2. You learned this skill forever ago. It still plays. So the coordinates of the dot after the translation, well, it should be 5, 2. So let's check. There's our dot. It's still going to be 5 across. Let's go up 1, 2, 3, 4, 5, 6, 7. And that is 5, 2. So when you're translating a graph up or down, you are going to add or subtract from the y coordinate. And just in case you forgot, x is first, y is second. Okay, so that is how to translate that one. Let's do the next one. We're going to, excuse me, do a similar thing. You've got a point with a large dot. You're going to first translate the figure 6 units to the right and then give the marked point. So first, what is the point in the original figure? It is -4, -6. Okay, there's the dot. I'm pointing at it. And we're going to translate 6 units to the right. So going to the right on a number line, remember way back when, 0, 1, 2, when you go to the right on a number line, you're adding. So we're going to go -4 plus 6, which equals 2. Now we're only moving it 6 units to the right. We are not going up or down. So this becomes 2, -6. And let's check. Again, we're not changing the height. Going 1, 2, 3, 4, 5, 6. There you go. Across 2, down 6. So there's the first page. All right, let's look at the next thing. Now we're going to combine them. All right, we're going to combine them. We're going to translate 2 steps. All righty, so first, the coordinates of the original point. There's the point. It is 4, -2. So now we're going to go 7 units to the left. I'm going to go 5 units up. So we're going to do 2 things. I'm going to do the math first, and then I'm going to show you on the graph. 7 units to the left would be 4, whoops, wrong color, is 4 -7 because you're moving to the left. And then 5 units up is -2 plus 5 because you're going up. All right, let's do a whole new color. What is 4 -7? It's -3. What is -2 plus 5? It is 3. Let's see if I'm right. So here's my dot. I'm going to go 7 to the left. So 1, 2, 3, 4, 5, 6, 7. Then 1, 2, 3, 4, 5. And there we go. negative 3, 3, negative 3, 3. So the math isn't hard. You just need to keep track of what you're doing. And I'll put it on this page also. Plus or minus your x-coordinate. And this is plus or minus your y-coordinate. I'm color-coding them for you, okay? When you move left to right, I've got that in blue. When you move up or down, I've got that in green to help you remember. Now let's do this one. There's the figure, there's the point. And I didn't translate the whole figure. Let's go back up here. I did not translate the whole figure. I still need to do that. My bad. So it says translate the figure. So let's do that. I'm going to do some erasing so we can actually see. Okay. There's the dot. Now let's do the figure. The figure went across 1, 2, 3. So we're going to go 1, 2, 3. The figure went down 2. We'll go down 2. And then went across 1. And then we connected it. Trapezoid. Okay. So there you go. There's your figure and there's the marked dot. Let's not forget to draw the figure. All right. Here's the same concept. The coordinates of the original point are 2, negative 6. We are going 5 units to the left, and we are going 6 units up. So now once you pause this, I want you to try it. Now I'm going to do it. All right. To the left means you're subtracting 2 minus 5. 6 units up means you're adding negative 6 plus 6. This becomes negative 3, 0. If I did it right, let's find out. Okay, I'm going 5 to the left from my dot. 1, 2, 3, 4, 5. Whoops, my 5 is right. I just shouldn't put my dot yet. 5. There, and I'm going up 6. 1, 2, 3, 4, 5, 6. Okay, there's my dot. Now I have to draw the rest of the figure. Down here it goes across 1, 2, 3. I'm going to go across 1, 2, 3. It goes down diagonal 2. I'm going to go diagonal 2. And then we're going to make a nice little parallelogram. Throwing in unit 4. Okay, so, and I proved it. Negative 3, 0 is the point of my dot. Okay? Now we're going to reflect. Reflect is a mirror thing. It's like folding a piece of paper. So whichever way you reflect, you fold the paper. We're going to reflect across the y-axis, which is this one, which means you're going across that one. Now, this is where people get confused. So when you reflect across the y-axis, what that means is your y does not change. Y-coordinate does not change. Because you are not making this go up or down. You are taking it from left to right or right to left. If you're going on the y-axis, you're going left to right or right to left. So let's write the point. I'm going to show you something. Here's the coordinate point, negative 4, 6. Now, if I'm reflecting it across the y-axis, all I need to do is change the sign of the x-coordinate. So it actually becomes 4, 6 to reflect it. Okay, now let's do some counting. Let's look at this, okay? We are 4 from the origin there, 4 from the y-axis there. We're 4 from the y-axis there. We did not move it up or down. We simply reflected it, so it is balanced. The y-axis is right in the middle. If we were to fold this piece of paper like if there was a big wet ink dot on A, it would go over and you get a big wet ink dot on 4, 6. All right? So when you are going across the y-axis, you change the sign of the x coordinate. So let's do some more. I'm going to write the original points. Whoops. So on this one, plot the reflection of the point A across the x-axis. Okay, throwing in another axis. Now let's use some logic. If I'm reflecting across the x-axis, which is going this way, does my x-coordinate change? No. I keep on saying using logic because I want you to learn more than memorize. When we reflect across the y-axis, the y-coordinate does not change. So if we reflect across the x-axis, the x-coordinate does not change. Now this point is 7, -6. Using your logic, what we saw when we reflected across the y-axis, what do you think I need to do to the y-coordinate to change it? And you're right, you reflect it. Change the sign of the y-coordinate. There's your reflection. 7, 6. So let's find it. 7, 6. All right? So same concept. Point A was a wet blob of ink. We folded the paper along the x-axis. The x-axis runs through the center. You are just as far here. Let's get yellow. The distance here is 7, and the distance here is 7. That's a reflection. All right, you're going to do the one here. I want you to stop the recording. I want you to try. Write down your original point, write down your new point, and plot it. And now I'm going to do it. All right, original point is 7, -6. I'm reflecting across the y-axis, which means I change the sign of my x-coordinate, becomes -7, -6, which goes over here. All right? It is not, it says label the point A prime. Sorry, forgot to do that. A prime, A prime, A prime. The little mark above is called a prime. All right? That way you can keep track of your points. You are going to do this in the ALEC system just like this. All right, now we're going to add a level of complexity. It's what we do. We started off simple. Now we're going to do a slightly more complicated. Okay, we're going to reflect over 2 axes, but we do it in 2 separate steps. So there's our point A. First, we're going to reflect across the x-axis. Then we're going to reflect the result across the y-axis. But we're going to plot and label our final point, even though we're going to mark up this graph. First of all, let's put the coordinate for our point. So, step 1, our point is 7, -3. Now, if we're going to reflect that across the x-axis, we are going to change our y-coordinate. We're changing the sign of our y-coordinate. This becomes 7, +3. So let's do that. 7, +3. That's our first step. Now, we're going to do the second step. We're going to take 7, +3 and reflect it across the y-axis. You change the sign of your x-coordinate. This becomes -7, +3. over there, negative 7, positive 3. So this is the final point you're plotting. This final point is A prime. So you did step 1, which was reflect across the x-axis, then you did step 2, reflected the result. Now, where people make mistakes, and I won't tell you how many times I do it, they reflect across the incorrect axis. So please, when you're doing this, pay attention to your x-axis and your y. Remember which one it is, so you remember which way to reflect. All right, we're going to do another one. It's another you try. So I want you to try it, and then I'm going to do it. So stop the notes and you try it. All right. Step 1, what is my point? My coordinate point is 4, 6. I'm reflecting over, I couldn't read it, reflecting over the y-axis. So I'm going that way. So this becomes, we're changing only the sign of our x, negative 4, 6. So that's my first one, my first translation. Translation. Now, my second one is reflect this result over the x-axis. So now I'm going down this way. So what coordinate am I changing the sign of? My y. I'm not moving across anymore. I'm moving up and down. This becomes negative 4, negative 6. Negative 4, negative 6, there it is. A prime, that is the dot I'm looking for. All right? So that is a multi-step reflection. You do things in steps. I've emphasized steps for quite a while with the algebra and geometry. Do things in steps. Do not try to jump from point A to A prime. Do it in the steps, and you'll always get it right. Okay, now we're going to find the coordinates of a point. Okay, you've done this on the coordinate plane, and we've talked about what you do. What did I say about reflecting across the y? Let's see, transformations. Reflecting across the y-axis. When you reflect across the y, you change x sign. You reflect across the x, you change y sign. So this is actually so much simpler than you ever thought. So reflect the point, negative 5, 6 across the y-axis. Oh, that's 5, 6. Reflect negative 5, 6 across the x-axis. That's negative 5, negative 6. Way easier than you ever thought. And here's the basic rule, which I keep on telling you. When you reflect across the x, you change the sign of the y coordinate. When you reflect across the y, you change the sign of the x coordinate. So you try it. This should take you 10 seconds. Did you get that? You probably did, because this is not complicated once you get this concept in your brain. All right, we're almost 2 pages of notes, but it's not a ton of work. Now we're going to reflect and give the coordinates. Okay, now we're doing it with figure, and you have to draw the figure. That's where things might get just a little bit tricky. So the point in the original figure is negative 7, 3. We're reflecting across the y-axis. So first, let's give the coordinates, because that's actually pretty easy. In the new figure, we're changing the x, becomes 7, 3, and then you're going to draw the figure. So 7, 3. Now it's a reflection. So whatever goes left on one side goes right on the other. All right, so this is 1, 2, 3, 4. So we're going to go 4. 1, 2, 3, 4. I'm going to go up 1. Here, we're going to go up 4. And then we're going to connect. And there's our figure. All right, once you get that point, then you just do the opposite from the other one. If the other figure, the original figure goes left, you go right. Now let's try this one. Point in the original figure. This is -7, 3. And we're reflecting it across the x-axis, so we're changing the y-coordinates. This becomes -7, -3. So let me put it here. 7, -3. All right, now this, if you notice, this point is in the top part here. It's going to be the top part here. So we're going to go 1, 2, 3. And we're going to go diagonal down and there and there. Sloppy, but it's there. Is that a reflection? It's not, is it? Oh my goodness. So what do I have to do? Still a little tricky, isn't it? Well, you're going to still go across. 1, 2, 3. But this now goes this way because it's a reflection. 2. It's a lot easier to do on a bigger graph, okay? If you're not sure, fold a paper. Draw it on a paper and fold. That's the proper one, all right? Hey, everybody makes mistakes, so you have to really be careful. Let's do the last one. You've got the large dot. Point in the original is -7, 3. We're reflecting across the y-axis, which means we're changing our x-coordinate. Becomes 7, 3. 7, 3 is where the dot goes. This one to the right. This goes to the left. This went that way. That way. This went to the left, so this goes to the right. Little diagonal there. Little diagonal there and there. All right? When you get it, if you do it in the software system, you're going to get some lovely drawings. It's going to make more sense. Last part is rotating. Now, rotating is when you're taking the dot and you're not just reflecting it, you're taking the entire figure and you're going, that's a rotation. There's the original and you're rotating. All right? So let's look at some rotation rules. And the rotation rules just make it easier for you. You've got the 90-degree counterclockwise rule. Switch X and change Y. And you change the sign of the new X. So, oh my goodness, that's kind of wild. So let's take a look. You're going to rotate the figure 270 degrees counterclockwise, which means you're going 90, 180, 270. That's a 270 degree rotation. This is where you're getting in a teeny bit of the unit circle. A circle has 360 degrees. Every right angle is 90 degrees. You have moved 270. So when we say rotation counterclockwise, we are saying go to the left. It means if you looked at a wall clock or at a regular analog watch, things would go around to the left, not down to the right like they normally do. All right, so the point in the original figure. This point in the original figure is 4, 5. All right, the point in the final figure. Well, this gets fun. So, 270 degree clockwise is like doing a 180 plus a 90. All right, so first, I'm going to do a 180. So, at 180, 4, 5 becomes -4, -5. So that's a 180. But we still have 90 degrees more to go counterclockwise. So then we go up here. And we're going to take -4, -5, and we're going to make it 5, -4. We switch the x and y, we change the sign. So your final point is 5. Oh, I actually put it close there. Final point is this. All right? Give the coordinates of the marked point in the original figure and final figure. We're never going to say rotate 360 degrees because that will take you back to the original point. Now you could do it counterclockwise that way. I'm going to also show you, and this is where you have to have a really good grasp of a coordinate plane. Okay, if a coordinate plane, I'll write it up here. Coordinate plane, 360 degrees, okay? Each quadrant is 90 degrees. If I'm going 270 counterclockwise, that's like going 90 clockwise. You have to get that in your heads, okay? So let's take a look and let's do it in blue. I'm going to do this in blue. So I'm going to take my original 4, 5, and I'm going to use this rule, and I'm going to switch x and y and change the sign to the new y. This becomes 5, -4. It's a short way. So when you're going 270 degrees counterclockwise, see how we went this way? It's like going 90 this way, 90, and that's 270. Okay? Study it, play with it, it will make sense. Okay, we're going to go ahead and we're going to try these ones. And my goal is to have you choose the simplest way. So first, let's give the point in the original figure, -7, 1. Now we're going to rotate 90 degrees counterclockwise. So we're going from here to this quadrant. 90 degrees counterclockwise says switch x and y and change the sign to the new x. So becomes, I'll just put this, -1, -7. Okay, we did not need to show a bunch of steps. I followed the rules. I switched x and y, and then I changed the sign of my new x. So let's mark it. -1, -7, -1, -7. That is my 90 degrees rotated point. All right? These rules up here are going to help you so much. Now let's do another one. Here's a figure. First, I'm going to write the coordinate. It's 4, -3. Now I'm going to go 270 degrees counterclockwise, which takes it from here to here. That's counterclockwise. But you know what I can do? Let's do it the easy way. Let's do 90 degrees clockwise. That means I only have to change the coordinates once. That's so much easier. I'm still going to get to the same quadrant. All right? So 90 degrees clockwise, I switch x and change y. It becomes y, -x. So this is y, -3, -4. And there's let me find my point. -3, -4 is right there. Okay? Follow the rules. And you can use the rules, I think you can use the rules in the summative, but follow the rules and you'll be fine. That takes care of day 1. It seems like a lot of material, but it's just a bunch of steps.